I'm Sarah Bryant. I'm the co-founder and co-director of the Shippensburg Area Math Circle. We are in rural Pennsylvania, in the small town of Shippensburg. We call it Shippensburg area because we don't have a requirement of any particular school, and we have had some students who have been outside of Shippensburg town, but have come into the town. And in the town is Shippensburg University, so helps people know kind of where we're at, where we're going to be having the lessons and stuff. So I wasn't sure how many people who would be on the webinar had worked with young people before, or if they were just thinking about it or had just started. And we're not experts in elementary education, but we have learned a couple of things I thought I would just share, and then we can launch into activities. Does that sound good? Or we could just talk about, I don't have to just share out, but we can talk about these things. Does that sound all right?
Sure.
Sure. So I have found that the students are pretty appreciative of and respond really well to having a set structure and routine. And it's also helped us establish, I think, relationships with the parents where they're pretty trusting because it's like a clearly, smoothly run operation. And so we always have a sign-in process. And there are various papers that we have the parents fill out on the first day. And then we always start and we say, come on in and join the warm-up. So there'll be a warm-up out on a table. And then there's a main topic of the day that takes the bulk of our hour and a half. And then at the end, maybe the last 20 minutes or so, we have snacks and games. We've alternated on whether to have snacks or not, because sometimes it can be a little all-consuming for the kids. They can be all about the snacks, and it's just this huge thing, and you have to go buy snacks and be careful with allergies. And we thought, it's only an hour and a half. Can you go an hour and a half without a snack? Like, I do all day, but we've landed back on having snacks. It seems like a nice thing to do at the end. So do you guys have snacks in your math circles?
I don't run a student circle.
Okay, yeah.
I work with people who have developed some kind of student circle at their school, and I go in and work with them.
Yeah.
Rather than having my own. So usually they bring some kind of snacks.
Usually a snack, right? We have about a 1-to-4 ratio right now. We're pretty lucky in that the grant has allowed us to hire students to help support the circle. And so we're running about a 1-to-4, but in my experience, I wouldn't go past about a 1-to-10 ratio. That would be a hard line. And I just say that we're kind of strict about behaviors in the classroom because we are on the university campus, and we just feel like we are able to enforce some rules and they'll just respect it because it's our space. And so we're pretty strict about roughhousing, running around, and that sort of thing. We really don't allow it, which is, say, different than my daughter's Girl Scout troop. When they land at Girl Scouts, they just go running wild, crazy, and it's just kind of allowed, and it's part of their culture. But in ours, we're pretty much seated, working on something, and we're pretty strict on that. We have had some issues with shyness, and I've noticed girls tend to sit at a table together, and I at first was trying to force a mingling, and I found that backfired. And when people sit socially where they feel comfortable, they may expand that social circle if you have activities that allow them to do that, but I think forcing it never really paid off for us. And we do have incentives and into the program prizes and certificates and that sort of thing that are always really appreciated by the kids. And I think it goes a long way towards helping them feel invested in their program, it's their program too. And I can skip a little bit of this Piaget stuff, but my point is that when you're constructing activities, you do have to be careful of the age of the group that you're working with because they're just not all developmentally appropriate. And we have a lot of mathematical things that are about abstraction, but it's known that development is not necessarily in place with 4th and 5th graders. And so you have to be realistic in your expectations of what they can do and that they're more comfortable operating in a concrete sort of setting. So so that's about all I would say. Just be really careful. Something might sound like a great idea, but not really be developmentally appropriate for 4th and 5th graders. And we've run into that. Even in terms of their physical dexterity, their like ability to use their hands. We did like origami and a couple of other things that they enjoy, but we have a good number of students who cannot make a good fold. So again, you don't want to derail your whole thing if you're expecting people to do something that they just can't do because they're too young. And the other things are more about managing your responsibilities and working with young people. That's what this is about. And these are lessons I took from like Brandy and others who have talked to me about having circles with young people. So just to share that we did adopt all of these policies ourselves too, like a signing in, signing out sheet where it needs to be parents, or parents have to have notified us, and we have to see IDs of people who are picking up kids. Our institution has a liability waiver, so we have this sort of a boilerplate liability waiver, and we have our student parents sign that. And we do have clearances for all of our helpers. So sometimes it's hard to figure out what's legally required versus what's encouraged by your institution, but just go with the stricter of anything that you can find. So in general, clearances are probably going to be required. Pennsylvania is particularly strict. And some other things have to do with behaviors of kids, and maybe you guys have seen these yourself, that sometimes kids don't speak up much, and some fidget, and we just try to address these things head on by acknowledging them, by providing fidget toys, by saying we're not going to force anyone to present or talk that doesn't feel comfortable doing that. And we allow for flexible seating so people can move midway, or we might relocate if necessary, but it's not like assigned seating. So that helps us to curtail some behavior issues. And I was just talking about every so often in our group, it's usually kids who like math all right. Usually their parents say they want them to be doing math. And even though we put on the flyer and we really emphasize it's for kids who like math or like puzzles or like games, we've had parents show up and go, she hates math, she hates puzzles, we hope you can fix this. Like, that's what I said I'm not going to do. And so when a child has clearly had a terrible time, we do talk to the parents, and we do say, you may want to think about sitting out the rest of the session and returning next time. We have a very low fee or no fee. We operate on a very low to no fee basis, and we don't even necessarily collect on the first day. Sometimes we'll say, if you're just trying it out, why don't you wait a few sessions? And our fee is usually about $10, and that covers all 5 sessions. And so we get snack and a prize and stuff like that. And we have had some gifted children who every so often are very, very sensitive to feedback and can be a little bit more emotional or easily upset if you suggest a different process than the process that came naturally to them that allowed them to solve the problem very easily. So that's when we fall back on the Math Circle Salute and the Math Circle Pledge, and we talk about the mentality of a mathematician and how it's not just about the right answers, and that we're just exploring different ways to think about problems, and so try to keep them moving. All right, so that's some of the stuff about working with kids. Does that align with your experiences, or do you have any questions or anything about any of that?
Nope.
No.
I would just add, Sarah, if you don't mind, I've had trouble with kids drawing good pictures also, in addition to origami and manual dexterity. One time I was doing an after-school program, and I gave the kids tangrams, and I said, okay, make a tangram to give your friend. And it was a disaster, right? Because they couldn't, or they want things to be the same, that look the same length to be the same length, but they're not, or, they don't look the same length, but they're supposed to be in the problem. And so I found the same kind of thing.
Yeah, that makes a lot of sense to me.
Yeah.
So I wanted to share some of our best activities. And in our experience, there's some activities that we as the directors or our guests who come in, we really love them because we really see how it's low entry and we can see that high ceiling on the problem, and we're just really jazzed about it. But for whatever reason, it's just okay. like for the kids. And then there are some that they love, especially the more concrete, not necessarily super big problems. And for us, it's just not as satisfying. So I thought I would sort of speak to the ones that primarily fall into we both really love them. We think that there's a lot that you can do, and it's really approachable for the kids, and they often rate these following activities really highly on our end of the program surveys. So I'll just share some of those, and for anything that you're interested in, I have materials for a lot of these activities. We haven't invented them. I don't think any of them we've invented, but we've just pulled it together and maybe combined several sources and made it our own in that way, but we haven't invented any of these. So sort of the greatest hits are a scavenger hunt, which allows us to introduce some cryptography and even just the basics, the really simple stuff, like a shift cipher or a Masonic or Pigpen cipher, or the Sci-Tail where you wrap around a rod. These ciphers really get the kids excited, and running around and exploring the space gets the kids very excited. So we can talk a little bit about that. And then, of course, James Stanton's Exploding Dots. I think that's pretty well regarded as a amazing activity. And so I'll just speak to what some of the practicalities of when we worked on that activity. MOBIUS strips, and the fun things that we've done with those. And one of the most highly rated ones from the kids, and maybe it falls more in what they love, is Math Magic. And I'll talk about the different Math Magic we show them. And then origami, always a hit. And we did some things that I had never done before, so I was pretty inspired the most recent time we did origami. So just to kind of walk through them, and I pulled these clips from our end of the session wrap-ups. We always send a sort of end of the session wrap-up home with parents to summarize the activities we did so that the parents know, okay, that's what this was all about. And we don't always know it ahead of time, day by day, and to the detail. So we give this as a parting gift, like something that they can look at and then maybe have additional time and resources to look up stuff that would go with it. So we usually have them make a little Caesar wheel for a shift cipher, so you can cycle through lots of things, and that just requires like the templates and then a little brad to poke through the middle. And then so not really high investment there. And then we have the wraparound to the Sci-Tail. And the thing that I would be careful about this is that it's really fun, run as a scavenger hunt, but you do have to go back to those behavior expectations, because I had kids who were just really with the program and understood our expectations on behaviors, but once they had free reign to kind of run down a hallway, then they ran down the hallway instead of, walking. And so having lots of adult help on hand for a day when you might have the groups more dispersed or exploring is, of course, crucial. So for most of the kids who we've worked with this was the first time they'd ever seen most of these codes. They might have a sense of things being shuffled, like shuffled letters, anagram style codes, but this really intentional and various processes thing they hadn't seen before. So then by the end, they're always like writing their name in codes and all of these things. So that's been a pretty fun one for us. Have you ever done a cryptography unit? And we don't get into, we tried to get into like modular arithmetic ciphers that would require more of that. And in our experience, our group was not able to really handle the mathematical processes in any kind of way that made sense to do an entire cipher. So we kept it to the really physical things like the Caesar, and you could try and you could wrap the thing around. We'd have various size rods, and they would have to wrap the paper strip around various size rods until they could tell which one was the right size, and the message emerged. And so it was something that, again, kind of drawing on that physical ability of the kids, that they could do that. Right. So that one was pretty fun. Of course, I think you don't need me to tell you that Exploding Dots is great. I would just say that we did a couple of things that I would do again, which is that we have wipe-off boards, like clear plastic wipe-off boards. And so we made boxes. We, made a template with just the boxes. And then we had the kids with their wipe-off markers and things, just exploding things and moving things around and trying a new problem easily. And this was one where we had the students come to the board and show work, and it was probably the most excited and most willing to come to the board that we've seen the kids. So I felt like it was a process that they really could understand, and then they got into some pretty interesting things, like quick multiplication and stuff like that. So this one is just completely enjoyable. I've got the link here, and be happy to talk about that one a little bit more if you have any specific questions about running that with 4th and 5th graders. Have you guys ever done exploding dots or seen it? You've seen it? Yeah. So it's good, right?
Yeah, but not with kids this little, so that's good.
Yeah, so just so you know, if nothing else, you get, it can be done. And they were very engaged. And they do some things that, this is natural, but they do some things that, like, at first they're doing very, very, like, before they figure some things out, they're taking a long time to do a problem. But I feel like that learning curve, like once they really talked about cooperatively, like some efficient ways of proceeding, it was a real big hit. It's a real big hit. All right. So I don't remember that we talked about bases necessarily, like that phrase. Sometimes when we want to talk about changing bases, we do the thing of like, if an alien that counted differently than us, counted this way, like maybe instead of 10 fingers, they had 4 each or something like that. So I don't recall that we said actually the word bases during the activity. All right. So MOBIUS strips are, of course, really just making one and tracing it, a ladybug path, that kind of thing. It's pretty fun. But quickly we realized that cutting MOBIUS strips is definitely the thing to do. And there are a few challenges out there. Martin Gardner has Martin Gardner's Surprise. Have you guys ever seen that one?
Mm-hmm.
So it's just called Martin Gardner's Surprise, and it's a T shape, and you put it together, one with a half twist MOBIUS strip style, and the other bit you put together just loop style. And after we've cut some MOBIUS strips, and the big thing that we work on here is not just MOBIUS strips, but what changes, what stays the same. You know what I mean? Like, what properties of an object change or stay the same after you do something to it. And then also, we've tried to intentionally every session incorporate something where they have to make conjectures. So we made them write down their conjectures in a journal this time. And okay, before we do it, write down your conjecture, what's going to happen, and how can we test that that's the thing that happened. And so that's just vocabulary of like how you anticipate something, and then how do you verify it. And so cutting the MOBIUS strip in half, of course, you get something different than if you just cut a loop in half. Something different happens. And then when you try to cut the edge off of a MOBIUS strip, rather than cutting it in half, maybe cut about a third of the way in, you get something else. And we had some kids come back the next time and say that they had continued to explore. So that's, to me, it's a big success if the kids are like, I did it, and then I went home and I did a MOBIUS strip with 2 twists, and I cut it, and guess what happened? So they're trying to make me conjecture on the spot. So, but that to me is a sign of a really good activity, that they kept doing it at home. That was a good one. And we found videos by, is it pronounced Vihart or Vihart? Do you know? The mathematician?
Vi.
Yeah. So she has a little video about this character, Wind, and Mr. Ugg. And you have to watch the video, but it's getting at the same thing. So we would watch some of the video, we would do some of our MOBIUS stuff, and we would cycle back to the video. So we kind of broke up the video in terms of, well, let's see what would happen, or let's think about what would happen. So she's got a whole thing where it's a clear MOBIUS strip, and she's traveling it. And of course, as she goes around, things are changing when she comes around. And since it's clear, the writing looks, you know, it's inverted and upside down or whatever. And so the character thinks that there is someone else on the MOBIUS strip with her, but it's just her. So it's this really interesting story. It's really fun. And then at the end, there's a tear, a rip like a dog appears. And then there's a tear, there's like a rip in the world, and it starts splitting apart and splitting apart. And the question is left hanging, like, will she and her dog be separated forever?
Oh.
And, but they were fully equipped to tackle that, and they cut. They realized that she was on a MOBIUS strip, and then they cut, and they're like, "No, it's fine. You can visit your dog. It's okay." And so that was a really good new thing that we added, was the video, and it's well done and stuff. So it's fun. And then just recently, they requested a little bit more MOBIUS strip, and so we found one where you can cut a interlinked MOBIUS strip hearts. So I hadn't seen that one before done, as a MOBIUS strip cut. So there's all kinds of variations, and having them do conjectures was probably our favorite part. All right. Cool. Let's see. All right. So mathematical or mathemagical tricks is a whole big bundle of activities. And most of them are fairly short, so you have to piece together a few of your favorites. One that I've seen for a long time is this magic gopher. Have you guys ever seen this magic gopher before? So you can go to this website, and when we post the PDFs and stuff, these are clickable links, but so I can send the link. It's a little long, but in any case, you could type probably magic gopher or something like that. And he's reading your mind, because he makes you think of a number, like a 2-digit number, and then you do some operations to it, and it won't ruin the surprise. But at the end, he gives you a sheet, and he says which symbol matches your new number, and he always knows. And so there's always a big, a big, huge gasp in the room the first time that he guesses. And then we do it again. And when you reload, he has new symbols. And the only downside to this is that because it's simple operations, it just has to do with multiples of 9, stuff like that. But it's simple operations, but some kids mess them up. So every so often there'll be a kid who go, "He didn't read my mind." And you're like, well, okay, because he's supposed to. So without putting them on the spot, you have to help them go back and recalculate their numbers and redo the process. So this one's really good, although they got a sense that there's something mathematically happening, and they really got a good sense of pattern. But there is not going to emerge from the 4th and 5th graders a simple little algebraic proof about why the result is always a multiple of 9. But they totally got there with regular concrete number reasoning. So so not only just exploring this and demystifying it, but saying why all the things happen that happen, they were completely able to do. And in fact, there's 2 multiples of 9 on the sheet that he gives you to guess from that don't have the same symbol as all the other multiples of 9. And so when they had a conjecture of it's all the multiples of 9, I said, but this one and this one don't have that same symbol. And they were able to reason out why, because you can never land at those 2 multiples. So I would say this is a really good one to see your kids work through. And even though my approach is completely algebraic, little proof, they're able to get there without that. A few other fun things you can do. I don't know if you guys have done the cut an index card so that you can pass a basketball hoop or a person through it.
Right.
So have you seen that? So that looks like math magic. and so we actually have incorporated that various times. We've done topology days, and that one actually goes pretty well with a MOBIUS strip exploration because it's cutting and changing a thing. And so there's just a pattern to it, and what you do is you give the kid scissors and a basketball, or say, make this so big that your partner can pass through it, and I'm going to try to do the same, and I do it, and they don't do it, and so it feels like, how is it even possible? So you just by cutting a hole in it. Of course, it has to do with the way you cut back and forth. So you're basically making this accordion stretchy index card, but it's still just cutting a hole in it. So that's fun. And then we just found a collection of other things. So I think Math for Love has a write-up about multiplying with the number 37. There are some patterns to multiplying with the number 37 so that they can seem like really whiz multipliers. And then there's adding up Fibonacci and Fibonacci-like sequences, and how you can add them up by noticing that it's just by doing something simple, you get the same result as always adding up the numbers. The only thing with these mathematical tricks is that it's hard to expand. Like, they're not going to come up with a new mathematical trick, but they might try to extend a few of them. And there are some that they understand, like the magic gopher, and they can reason through why it works. And then there are some that we haven't yet seen the kids understand why it works. And you don't want to be like really trying to make math seem like magic. So depending on how many you choose to do, you may want to say, I'm only going to do as many as I know I can really show them how it works, not just like amaze them a bunch. So, which is a little bit tempting. So, gotta be careful. Do you guys have any math magic tricks? And we do some magic card tricks too that are just about modular stuff. But do you have any math magic tricks?
I've seen some. I don't tend to choose sessions like this.
Yeah. Well, what's fun is, especially maybe as a first session, it's very icebreaker-ish.
Mm-hmm.
And sometimes some kids know some tricks too. And so it can be a way of talking about the fun of playing with numbers and stuff like that, or doing things that at first seem really difficult, but when you figure it out, they're not so difficult. So, so it's kind of a fun icebreaker-ish type thing. Yeah. Okay. And then, origami, which I've already said this, you do have to be careful about their ability to fold. So frustration can emerge with origami. But we actually did modular origami, transforming, or like the moving origami. So the shape in the bottom here changes. So that's it, collapse, and then it expands, and collapse and expands. And we found a really cool TED Talk, which talks about the origami that is used in various places throughout the world, so that they got a sense that that thinking of these things as artistic, but also very useful. And so we had them think of like, where are some ways, or what are some other ways that origami could be useful to you? And they were like, if we could fold our backpacks. Thinking of silly things, but there was a lot of emerging, like, I don't know, a couple of our kids kind of emerged as leaders because they were good folders, and they could like help a few other people who were bad folders. And we also just touched on some theorems, like the one cut theorem, stuff like that. So talking about paper cutting as well as paper folding. So that one was pretty good, and we had them attempt several of the things like the one cut letters or one cut shapes. So they got to do a lot of trial and error with it as well. And this is one of the days where we did a strategy that we do about half the time, which is not a full group activity, but stations. So this one we had someone set up at the modular origami station, and you would make a box or another thing, and someone else was at the transforming origami station, and someone else was at the paper cutting station, an adult leader. And then the kids got to do about 2 of the 3 during our session. So we let them pick, and the tables kind of just moved around about halfway through. So that's pretty good, because our size has gone from, when we started, we might have maybe 6 students, and now it's sometimes up to 19, 18 students. So breaking them up into small groups is a really good thing. So having an activity that you can throw out to different tables is a good way to make those groups smaller. Okay. All right. So I have a few other that maybe you guys have done. Rational tangles. So that one's really fun. I did invest in some good cord, like a thick rope from Lowe's, and I found that was more enjoyable than the dollar store jump ropes I had. It all works, but I'm going to do this so many times. I'm glad I went to some cord. We also made little templates, like little things like this with shoelaces, so that at the tables they could try some of the moves and try to keep track of them. And also you'll find out there's different names for these moves. So you want to pick something that you'll remember and just doesn't have the same letter for both. So like twist and turn is no good. And, and I found that the funny ones like that Amanda 70 does or whatever, they just didn't stick with me. So we just kind of went with rotate and twist. I can't remember, rotate and twist, I think. And just keep it simple. Oh, and I would say here, for this one, the ability to work with fractions is not quite there with our kids. So that means that the level of problem you have and the connection you have to the fractions is reduced. So so they're thinking through some things, but it's the connection to fractions and the ability to kind of really go with this is not quite there for our 4th and 5th graders.
So how much do you do for them in working out the operations?
Yeah, I do a fair bit. I have to do a fair bit of the operations for them. So we can do some simple things, and we can make some observations, because there's some things that kind of emerge, like what would be undoing this and what would be undoing that, that they can explore in a really concrete way with the ropes. But I wait to make the connection to fractions, and then I wind up having to do a lot of that.
Right. So if there's a reciprocal involved, they haven't maybe even run into that.
They maybe have. So they have a kind of working vocabulary for fractions, but then their ability to do some things with them is not quite there. At least in the group that we had twice when we've tried this before. I think right now our group, we didn't do this time, but I think they might have been able to do it. We had more 5th graders this time. So so when you want to do, what is it that you do? You're going to be reciprocals and then adding, and that's where the difficulty is.
Yeah, the adding thing isn't too hard to nudge, I think, younger kids to, but the negative reciprocal thing, or
yeah,
adults have a hard time with that often.
Yeah, exactly. So when I do this with more of an adult audience, we kind of discover the operations, what are the appropriate operations that would match this kind of story we've got going here. But with the kids, it's that isn't going to emerge, and then doing the operations themselves can be so tedious that you're just the rope thing kind of gets lost in the tedium at the board. So it has to be short examples and stuff. And you can work out a few that are fairly short. You just don't want to get yourself into a jam where you're going to be up there for half an hour whittling this thing down. So yeah, so that's a thing. I would say just be cautious with this one if you're working with 4th and 5th graders. You guys have maybe seen the Frogs and Toads game or something like that comes up in Julia Robinson Math Festival. And we had some kids really do well with this and not even require the building block steps. But it's nice to have it. And we have a nice printout that we use for that one. there was a write-up about impossible cylinders. Did you guys ever see this? Impossible cylinders. So I can link to the source material, but it's these folds on a paper so that the paper looks one way. It's a cylinder paper, and the paper looks one way. Maybe it looks like it has a square top when viewed one way, but if you put a mirror in front of it, in the mirror, it looks like it has an oval top. So it looks impossible. How can I be seeing a square, but in the mirror, I'm seeing an oval? And so it has to do, of course, with like the cross section, like the view from both sides. You get a different view of the cylinder. And Dave Richardson did a nice write-up of someone else's original work, but I can link you to the write-up that we used. The only thing I would say is that the whole write-up and the whole exploration of it, you're often putting this cylinder in front of a mirror. And so we thought, how can we have a mirror with these kids? And we want to be safe. So like Lance bought like non-shattering mirrors, like 2 non-shattering mirrors, okay, that they'll stand this way. Completely not necessary, because the kids realized that just by running around the table, like if they were on this side, it looked one way, and if they ran to the other side of the table, the shape looked totally different. It looked circular versus square or whatever. So you don't have to buy special supplies for this particular activity. You can just have them walk around the table, because it's the same effect, and they actually preferred that. So another thing that we did was a wrap-up activity, a family game day. So when you're working with younger people, their families are not necessarily all mathematicians, but they may really like games and maybe don't have as much exposure to all the kind of lovely logic and math-oriented games that we always love to play. And so we invite the families, and we have loads of games out, mostly from our personal collection, some from the math department. And we have a sheet that they can take home with all of the games listed, like a little picture and like the game listed, so that, you know, and the price or something like that. Because it's kind of like shopping around for a fun family game. And the parents really appreciated that. The only downside to this is that even with the rules out, we found that some families, because we had so many families and we had games scattered all around, and we only had so many helpers, we couldn't be at every single game. So a lot of the families were kind of like stuck. They were like, we don't know how to play this game. We don't know what's going on.
So what are some favorite games that you used in this?
So we like Blockus. Families seem to like Blockus. Let's see what else. So Set. This is really fun because it's one of our warm-up games, and the kids have become, you know, kind of comfortable with it, and they love showing off to their parents. So Set, Blockus. Let's see. On the Dot. You guys done On the Dot?
Mm-hmm.
Yeah.
So On the Dot is one of our, now it's kind of rivals set in terms of the favorites of the kids when they come in for warm-up. It's got 4 sets of 4 cards that are clear except for colorful dots. And you're going to pull up a card and put it in the middle, and every person has to use all 4 of their cards to make the dots arrange to match the card.
That sounds kind of like Swish.
Yeah, I think it may be like Swish.
Mm-hmm.
Yeah, I haven't played Swish, but I've seen the picture of it, so I think it's a lot like Swish. So you're trying to make your cards match some model, and everyone has the same model. Yeah, so it's called On the Dot. Little deck. We also have put out like Mancala and Prime Climb, and so in some of them we have like little logic puzzles where you have to put in the pieces to make a maze work or whatever. Let me think. I'll have to think. I'll have to look up my collection. But
I asked especially because we have a new math group that's formed to improve our public schools here, and I'm part of it. And we've had a couple of teacher workshops for 4th through 6th grade teachers, but we're about to have a family math evening.
Yeah.
About 5 schools in the lowest performing area of town. So this is these are good ideas for adding to the mix.
Right. I think that, at least a couple stations we would put out some of the same things that the kids had done, like frogs and toads or wolves and sheep, or even have origami paper. That seemed to be good. Tangrams, we have some sets of tangrams, but actual board games, like we've got loads, and I'll just have to think on it and give you my list, my recommended list. So there's also one that's origami-ish called Manifold, I think it's what it's called. Have you guys seen that? So it's these little, it's the size of a deck of cards, and each sheet of you kind of rip out the sheet, and then the rule is that you want to make it into a 4x4 grid with one color on one side. I think it's black on one side, white on the other, and all other squares hidden. And it gets
is that this thing here?
Yes, that's it.
Okay,
that's it.
I haven't had a chance to play with it, but
yeah, you'll really enjoy that.
Okay.
So those are often kind of a hit with the parents. The parents like puzzling through that. And sequence is not too bad, but that's not really mathy. Racco, this is the one I'm thinking of. Racco, it's kind of an old-fashioned game, but
how do you spell it?
Racco, RACK-O, I think. Racco.
Okay.
And let me see. I don't know if I'll be able to find it right. Racco. Yeah, that's it. I don't know if you guys can see my screen, but yeah, it's called Racco. So in that game, you're drawing cards, and you have to get your cards organized from lowest to highest in a rack kind of thing. And the first person to do that wins. So there's strategizing and probabilities and stuff in terms of should I throw this card out and hope for a better one, or what have you. So that one's pretty good. And we also put out our manipulatives. So we bought for our group space chips and zone tools. And they each, at least the zone tools, comes with some prompt cards that you can have out in addition to just free play and building things. And then the space chips, usually people are just building things with space chips.
Have you tried for that sort of thing doing Brussels sprouts?
No, I don't know Brussels sprouts.
Google it. It's a John Conway game.
Oh, okay.
All you need is paper and pencil or dry erase board.
Right. Sometimes we have out, it's a little different, but we have out the game of Hex, especially if we've taught it to the kids before. And that's also one where you can print a template and have out dry erase boards and stuff. Sprouts. Okay. All right. Cool. Yes. And then I think, let me see, where was I? Oh yeah, Wolves and Sheep, which is, has everyone played Wolves and Sheep?
Yeah.
The puzzle. It's kind of a tough puzzle. It's simple rules. You're trying to hide some sheep from some wolves on a board, and I'd have to get the grid. I'd have to look up the grid size and numbers, but the wolves can move like queens in chess. So they have these diagonals and horizontal verticals. And so somehow you have to hide the sheep among the squares and place the wolves in just the right way so that the sheep are safe. Mm-hmm. And it's a tough game. And I think one of the lessons it tries to teach is patience. So I wouldn't expect that to be a quick warm-up activity, but having it out may be nice during a family event or something. And this is one of those where we made a little template thing. So you can play this with just grids and X's and check marks or something. But like I said, the kids are sometimes better with manipulatives, something they can move around. And you can use chess pieces. We made these little sheep and wolves that you can cut out, and then they're the same size as the grid, so you can place them around. But wolves and sheep is a pretty good puzzle. And then I will say one thing that happened that was a little moment was we had a guest and they were doing river crossing puzzles, and but they use the terminology about cannibals and missionaries. So even though I really liked that day, I really liked the approach and the solution and everything that he showed. You know, sometimes these things have been around for a while and you're not thinking about the language associated with them. And I would say just don't use cannibals and missionaries and offensive looking pictures when you're trying to describe this particular puzzle to kids. Like adults can like go, oh my, can kind of groan it off, but like I don't want to, you know, show that to kids. So those are a few of our, you know, kind of greatest hits and stuff that we did that was super fun.
Mm-hmm.
And that's it. That's all. Happy to talk about any others.
Thank you, Sarah. This is great.
Yeah.
No worries.